Hi everyone. So in this video we will talk about 2D collision detection. Okay, so there are some examples given on the Mozilla MD and docs, and you're also given the conditions in under which a collision happens. So what I will suggest is you take it as an algorithmic problem to solve, given two boxes of different, let's say, height and width. You need to come up with a logic that basically tells whether these two boxes are intersecting or not. Okay, so this is, you need to think of an algorithm. Okay, so I will discuss a very simple case when these two boxes are squares, and we can use this code directly to build a function for checking collision of in our case. Okay, so for example, these are the two boxes, so these are the two objects. So we will treat our players and enemies as square or rectangular objects, and we will try to fit this code to detect collisions. Okay, so what we will do is, let's see. So basically we can actually move these boxes. So if you see, if the box becomes green, that means the collision has started happening. So this is a very small example, but an interesting one. You can see, even if there is a small overlap between the two boxes, then also there is a collision. Okay, you can also use circular collision detection because your COVID particles are circle, and this type of a collision detection can work actually better in this case. Okay, so but anyway, we will go with the rectangular collision detection. Okay, so let us try to understand it in a very simple terms. Let me give you two squares. Okay, let's say this is one square, this is another square, this is x1 comma y1, this is x2 comma y2. Okay, so if the collision is happening, then I must have x1 minus x2. That means this distance along x-axis, this should be less than this particular width. Let's say this is w. Okay, and also it is possible that this distance is smaller than this width. This is x1 y1, this is x2 y2, but still there is no collision that is happening. So that means the distance along the y-axis, that is y1 minus y2, this should be also less than equal to this particular height. Okay, so if this happens, then it means there must be some overlap like this. Okay, in this case you can say x1 minus x2 is less than the width, and you can also say this is y1, this is y2, this is also less than h. So y1 minus y2 is less than h. So if these two conditions become true, then you can say definitely there is a collision. But if any one of these conditions is false, then there is no collisions. Okay, so similarly, if they have written these conditions for all the four corners, you can take absolute value, you can write multiple conditions, you can actually verify it yourself that these two conditions are true. So let's see how we can use this code to write a collision detection function. So I will go to brackets, and here I can just write a helper function. Function is overlap. Okay, is there is a overlap or is colliding, whatever you want to call it, and here you put these conditions. Okay, so if rectangle1 dot x, so we have a property called width. We will pass the objects, they have a property called width instead of height. It's h, I will make it as w, I will make it as h, and I think it should work. So we can just write return true in this particular case. Okay, so these are the conditions. Okay, otherwise I can say return false. So we can call the function in the update function to check overlap between, let's say, player and the gem. Okay, so let's first check the overlap between player and the gem. Okay, one more thing we should do is we should pass the rectangle objects, rectangle 1 and rectangle 2. So these two objects can be any object because we have players, we have enemies. So any one object can go into this as a parameter, okay? Because they have these properties x, y, w and h. So in the update function we can check if the function is called as is overlap, is there a overlap between, let's say, the player object and the gem object. You can say console.log you won the game. Okay, let's see, and you can see we are continuously getting u1 u1 u1. That means our collision detection function is working fine. And what we can do is we can actually stop the game loop. Okay, so we can say alert you won the game, and we can actually return from this function. And in the game loop, okay, let me take another variable in the init that basically says game over equals to false, and in the once the game is won, you can either go to the next level or you can just say game is over, that is true. And in the game loop you can check if game over is true, then you can break the loop. Okay, so you have this game loop, you want to come out of this game loop, so you can call a function called clear interval, and here you will give the interval f that needs to be cleared. Okay, it says you won and u1 it means okay. Let's also try to do the collision detection for, okay, we need to see the coordinates when the first collision happens. You can verify it yourself, maybe because it is possible the effective image size is like this, I'm not very sure, and this could be a reason for early collision detection. Okay, but you can just see why it happens. Okay, so you can debug it yourself. Okay, the another thing that we need to do is to detect collisions between the enemies and the player. Okay, so let's write that logic as well. So you can say if is there a overlap between enemy, so we need to iterate over all the enemies. Okay, so for okay, one thing we can do is we can, when there is a overlap, we can first call the draw function so that we see the updated state of the game before finishing it off. Okay, anyway, so let's see the collision with the enemies. Okay, so I think that is something you can do it on your own. So let I equals to 0, I less than equals to enemy dot length I plus plus, and here you can say if there is a overlap between ith enemy and the player, then you need to reduce the health of the player by some factor. Okay, so what you can do, you can start with some initial health and then you can keep on reducing it. So let's say the player has some health, let's say health is 100. When the player moves, let's say the health is increased. Okay, so if the player is moving, you can say okay, player dot health plus equals to, let's say, by 20, you increase the health. but if there is a overlap between enemy I and the player, then you have to reduce the health. Okay, so let's say player dot health minus equals to 50, and if at any point of time if the health becomes negative, okay, so if player dot health becomes less than 0 at some instance, you can say console dot log player dot health, and you can say game over. Okay, so game over equals to true, and you can say alert game over, and the health you have is player dot health, something like this you will have. So let's try to go through, and let's keep standing here. Okay, str is not defined, sorry, this should not be like this. So it's in Python actually. So it says the health is minus 40 and you got a game over message. So in this case also we have to stop this. If game over is true, we will clear the interval F. Okay, so that's all for this video, guys. The one last thing that you can do is you can actually show the score on the top. So you can make another statement. You can say, okay, I will display the score on the top. So you can go to draw function, and here you can say pen dot fill style equals to white, and you will display the score. Pen dot fill text, and here you can say score plus score, and here you give the coordinates where you want to display the score. Score is not defined. Okay, so score is not there. Score is basically player dot health. So the health is equal to score. Okay, so you have a higher score in the beginning, and you can see finally you have a score 400 and game is over. So that's all for this video, and I hope you would have enjoyed watching this section, and see you guys in the next video.